Today we're talking about the properties of kites, and you've known what kites are since you were a small child. Hopefully you flew some in the windy air that we get around here. So what are some characteristics of kites? One of the characteristics is that it must be a convex quadrilateral. As we learned in the previous lesson, convex and concave means that it's like there's a dent in the polygon. It's sort of caved in. So if you look on the right here, this sort of looks like a kite that was caved in. If I had pulled this point out, it actually would make a very good kite, but because it's concave, it's not a kite. Kites are only convex. Another characteristic of kites is that they have two pairs of congruent sides. So I have a pair here, and I have another pair on the bottom, and there it is. And then I have a pair on this kite, and I have another pair here. And while for this image right here in the middle, this rhombus, all four sides are congruent. So that can't be a kite because it has four congruent sides. Go ahead and write that in on your notes. And while we're at it, let's go ahead and say can't be concave. Can't be concave. All right, this is why I have most of your stuff pre-written. It's a little hard to write with these things. Okay, so what's another characteristic of kites? None of the sides are parallel. So you can, if you look at these top two segments on the kite, those are not parallel. And this is not parallel to the opposite side either. If I look at this parallelogram on bottom, I have two sets of parallel sides. So that is why it cannot be a kite. Even though I have two sets of congruent sides, can't be parallel. Can't be, and I apologize for the handwriting, parallel. All right, can't be parallel. Another thing about kites, opposite sides are not congruent. So that's another reason this parallelogram can't be a kite. Over here you can see I have congruent sides, but they're actually adjacent to each other. They are consecutive sides, but they're never the opposite sides are congruent. The diagonals are always perpendicular. So, there we go. I'm trying to draw draw my right angle. All of those are right angles there in the center, and so the diagonals are perpendicular. And exactly one pair of opposite angles is congruent. So here I have one pair of opposite angles is congruent. I also have the same here, but what you're going to see is it's a little harder to draw because that diagonal's in the way. I have a pair of opposite angles that are congruent. Now the diagonals of kites are very interesting, so I gave it a whole square on the top right here. Diagonals bisect the kite into two different pairs of right triangles. I don't know if you can see the right triangle. Let me switch to a highlighter. And so if you look over here, this is one triangle, and this is the other triangle. That's a pair of congruent triangles. Then you also have a pair of congruent triangles down here on the bottom. So it bisects the kites, both of them put together bisect the kites into two different pairs of congruent right triangles. Now, one of the diagonals, in my opinion, is a little more special than the other one. And that diagonal is the one that splits the kite in half. It is also called the perpendicular bisector of the other diagonal. So you can see the short diagonal is cut exactly in half by the long diagonal. But the long diagonal here is not cut in half. You can see the top part is a little shorter than the bottom part. The same diagonal is also the angle bisector of the only pair of opposite angles. So if I go to my pointer here, and here I'll change ink color. Go to blue. So what I can show you here is this bisects this angle here and that angle there. And it also bisects this pair of angles right there. The other diagonal is not a perpendicular bisector or an angle bisector. Now let's go ahead and take a look at an example. The edges of the kite-shaped glass and the sun catcher are sealed with lead strips. segments JH, KH, and LH are 2.75 inches. So here's JH, the short segment, KH, and LH. So all of those are 2.75 inches. And then this longer piece in the middle is 5.5 inches. And they want to know how much lead is needed to seal the edges of the sun catcher. So I worked this problem out to figure out all of the edges, the center and the edges. Well, first of all, one thing I noticed is that since these are congruent here, then this is actually an isosceles right triangle. And I kind of just use a shortcut. I know if one side is 2.75, one leg is, then I can just multiply that by the square root of 2 to get the hypotenuse. If you're not sure quite how I got that, you could use a proportion to find this long side on this right triangle. Well, since that side's 2.75 times the square root of 2, then I can fill in those two edges. I only need to find the bottom two edges now. So I notice that this is also a right triangle. I know the top's edge is 2.75 and the long leg is 5.5, but I still need to find the hypotenuse, so I use the Pythagorean theorem. 2.75 squared plus 5.5 squared equals c squared. Using my calculator, I go ahead and calculate it, and I get the square root of 37.8125 is c, or 6.15. I went ahead and rounded this to the hundredths place. So the total lead is going to be the insides plus the edges. So the total is going to be these three short pieces in the middle here, there, and there, plus the long edge, long inside, and plus the two edges on the outside, the two short ones, and the two long edges. And when I calculate all of that, I get 33.83 inches. In example 2, we are trying to find the angles in a kite. So they tell me that angle WXY, this angle here, is 104, which means the opposite angle is also 104. And they also tell me the angle VYZ is 49. The first angle they want me to find is the other angle that goes with this, VZY. Well, one thing I can do is go ahead and draw a triangle, and I have the 49 degrees in there, 90 degrees because diagonals always make 90-degree angles because they are perpendicular to each other in kites. Then I just use the sum of the angles, must be 180 since it's a triangle. 49 plus 90 plus the measure of angle VZY is equal to 180. 49 plus 90 is 139. And then I subtract 139 from both sides, and I get the measure of angle VZY is 41. The next angle they want me to find is VXW. So it could be tempting to say, oh, let me just cut the 104 degrees in half, but that wouldn't be right because this short diagonal is not an angle bisector. So what can I do? Well, I already found out that this angle on the lower right here is 41, which means that angle is 41. So these two angles have to add up to 104. So the measure of angle VXW plus the 41 must be 104. I subtract 41 from both sides, and I get 63 degrees. Now to find the last angle, which is XWZ. So it's this entire angle here. Well, because I've got diagonals in this picture, I went ahead and redrew it, the kite without the diagonals. I put in my 104 and 104. And I'm really looking for this angle here, angle W. I can figure out angle Y, XYZ, because half of this angle is 49. Remember, the long diagonal is a perpendicular bisector. So I only have to multiply 49 by 2, and I get 98. So I have a quadrilateral. The angles have to add up to 360 degrees. So I say that my mystery angle here, plus 104 and 104 and the 98, has to equal 360. I add my numbers that are there on the left, I get 306. Subtract 306 from both sides, and I get 54 as my answer. In this example, I've got a kite here, and I'm trying to find this angle. You could say that's a vertex angle. In fact, you can see we only have one diagonal drawn here, and it looks like we have two isosceles triangles that we cut the kite into. Now, I have this pentagon here. I can tell it's a regular pentagon because there are all these congruent angles, and also all the sides are congruent. Well, I can find the total number of degrees for a pentagon using the sum of the interior angles theorem, n minus 2 times 180. There are 5 sides minus 2 times 180, or 3 times 180 is 540 degrees. So if I add all of these angles together, I must get 540. Well, I'm really only looking for one angle, and since it's regular, all the angles are the same. So I can just divide the 540 by the 5 for the 5 angles. And I find that each angle is 108 degrees. Now that I know that this is 108, this big angle here on the opposite side, here, let me go ahead and show that to you. This angle right here must also be 108 degrees because that's a vertical angle. All right, so that's 108 degrees. I went ahead and redrew my kite with 108 degrees in it, and I know that both sides, both the opposite angles, are 108. So now that I add them up, and it's a quadrilateral, so the sides add up to 360. Well, the angles add up to 360. So x plus 316 equals 360. Subtract 316 from both sides. And my answer is 54 degrees for this angle x.
Now we're looking at the writing prompt. It says a pair of consecutive angles in a kite are blank supplementary because. So what I did is I set up here an interactive set of angles. This angle and this angle are always supplementary. No matter how I move this point, these two angles will add up to 180 degrees. Now, you can see that it doesn't look really very kite-like. Now, I could change it. It starts to look like a rhombus, but it's not quite working out like a kite. Let's say I try to make this, there we go. Make a pair of congruent sides there and say, well, maybe I can make a kite this way. Well, the problem is it won't let me move this point D over here because it has to keep these two angles supplementary. Well, let's say I move this over here a little bit. Oh, okay, now I'm starting to get more like a kite. But the thing is, I really need to pull this point D over here and it won't come. Why won't it come? It's because I can't make the angle bigger than 108 because that would have to make it supplementary. So can the two consecutive angles for a kite be supplementary? And hopefully you realize that right here they cannot.
So first of all, a pair of consecutive angles in a kite are never supplementary because, first of all, that would make a pair of same side interior angles. What we were finding is that I created a pair of parallel lines. If the angles are same side interior, then the lines or sides would be parallel. If the sides are parallel, then it could not be a kite.